Booster 19 completed stacking in just 4 weeks. Version 2 took 3 months. Ship 39 is almost ready for cryo testing, and SpaceX just rolled the LOX header tank into Gigabay 1. But here's what nobody's talking about. V3's entire fuel manifold architecture has been completely redesigned. What's the breakthrough that's slashing build times by 75%? The answer lies in an asymmetrical design philosophy that defies conventional rocket engineering. Let's dive right in. Here's where things get fascinating. While everyone's focused on launch dates, the real revolution is happening inside Gigabay 1. The LOX header tank installation on Booster 19 marks the 70% completion threshold, with only the methane tank and forward section remaining. These aren't complex components. SpaceX has manufactured them hundreds of times. But the speed is what's shocking, from first ring stacking to near completion in under a month. What changed? The answer becomes clear when you compare the aft sections. Booster 17's scrapped remains and Booster 18's hardware tell a story that's easy to miss. V3 abandoned Symmetry entirely. The fuel manifold is completely reconfigured, the LOX header tank positioning is different, and the center COPVs are gone. This isn't an upgrade. It's a fundamental rethink of how Super Heavy operates. Here's why this matters. Version 2's symmetrical design looked elegant, but elegance costs time. Every perfectly balanced system requires precise alignment, careful integration, multiple verification steps. V3 says, forget perfection, optimize for function. The asymmetrical layout groups systems by operational logic, not aesthetic appeal. This reduces installation complexity, cuts integration time, and here's the critical part, makes troubleshooting exponentially faster. Test Tank B 18.3 proves this approach works. On December 11th, SpaceX began test number 8, running for 7 solid hours until 4 a.m. the next morning. 7 hours of continuous stress testing. This tank has become possibly the most tested hardware in Starbase history, and each successful test validates another aspect of the V3 architecture. When you're pushing test articles this hard, you're not just checking boxes. You're hunting for failure modes before they can hurt a flight vehicle. Now let's talk about what those unspectacular-looking raceways actually accomplish, because this is where the engineering gets beautiful. Ship 39 just received its CH4 and LOX autogenous pressurization raceways, those exterior pipes that most people ignore during launches. 6 Raptor engines consume approximately 5 tons of propellant per second, not per minute, per second. Each engine burns roughly 865 kilograms of liquid methane and oxygen every single second, split at a 3.6 to 1 ratio. About 188 kilograms per second of methane, 677 kilograms per second of liquid oxygen. Scale that to Super Heavy's 33 engines at sea level, full thrust. We're looking at 28.5 tons of fuel consumption per second. Remove that much mass from the main tanks without replacement, and you'd create a vacuum that would crush those tanks like a soda can under a hydraulic press. Those raceways bleed gaseous propellant directly from the engines back into the tanks, maintaining pressure as the liquid drains away. It's elegant problem solving. Use the engine's own exhaust to solve the problem the engines create. This is why Ship 39's testing matters so much. A cryo test before Christmas isn't just a milestone. It's validation that all these systems work together. The pressurization raceways, the redesigned plumbing, the V3 architecture changes. Everything has to function as an integrated system, not just individual components that test well in isolation. Meanwhile, the Gigabay construction is revealing SpaceX's true ambition. Crane segments arrived this week to lift the 4 massive building cranes higher as the structure grows. These aren't just construction cranes. They're going to lift the roof decking into place, building the facility from the inside out. The current height? Expect more than double what you're seeing now. This isn't about building starships faster. It's about building an entirely new category of manufacturing capability. 3 starships per day, 1 finished every 8 hours. People keep asking why SpaceX would need this production volume, and the answer is staring us in the face. Because Starship isn't just a launch vehicle anymore. It's becoming infrastructure. The moment you can manufacture orbital-class spacecraft as quickly as commercial aircraft, everything changes. Satellite deployment, orbital refueling, Mars logistics, point-to-point Earth transport, all of these become economically viable at scale. K2 Space figured this out early. Their mega-class satellite platform features a 3-meter by 3-meter payload deck, delivering 20 kilowatts of power, 10 times more than standard constellation satellites, for just $15 million. They're not miniaturizing technology. They're supersizing it because rockets like Starship and New Glenn can now lift these massive payloads affordably. K2 raised another $250 million this year, scaled from 25 to 90 employees, and secured a $60 million Space Force contract for their Gravitas mission launching February 2026. This is the ecosystem shift nobody anticipated. Starship's existence doesn't just make launches cheaper, it fundamentally changes what you design for space. StarCloud deployed an NVIDIA H100 GPU in orbit aboard their StarCloud 1 satellite. It's the most powerful space-based computing platform ever launched, training AI models like Google's Gemma and OpenAI's NanoGPT directly in orbit. Why? Because space offers constant solar power and radiative cooling and vacuum, infinite energy and infinite heat dissipation. StarCloud projects tenfold reductions in both energy costs and carbon emissions versus Earth-based data centers. CEO Philip Johnston predicts that within a decade, nearly all new data centers will be constructed in space. Jeff Bezos agrees. Elon Musk recently announced SpaceX's interest in orbital data centers. When the world's most successful entrepreneurs converge on the same idea, it's worth paying attention. But here's the infrastructure challenge nobody's discussing. Space weather. Solar activity can destroy satellites, damage power grids, disrupt GPS, knock out communications. NASA just selected 2 missions to study this threat. CINEMA, cross-scale investigation of Earth's magnetotail and aurora, will investigate how space weather impacts Earth's technology infrastructure. CMX, the Chromosphere Magnetism Explorer, will make the first continuous observations of magnetic fields in the Sun's chromosphere using ultraviolet spectropolarimetry. These aren't just science missions, they're insurance policies for a space-based economy. You can't build data centers in orbit if you can't predict solar storms that could destroy them. The technology stack requires the science foundation first. Version 3's asymmetrical design philosophy extends beyond just manufacturing speed. 3 grid fins instead of 4 means the booster will glide exclusively on one side during return, increasing downrange capability without fuel expenditure. By positioning Chinese into the wind and shifting weight to one side, Super Heavy becomes aerodynamically stable during descent. For a cylindrical object, this is counterintuitive engineering, but it works because SpaceX stopped optimizing for what looks right and started optimizing for what performs best. So here's what SpaceX actually accomplished with V3. They didn't just make Starship faster to build, they rewrote the rulebook on how aerospace manufacturing works. 4 weeks from first ring to 70% completion, asymmetrical design over perfect symmetry, function over form. Every decision optimized for one thing: speed without compromising reliability. Ship 39 will likely roll out for cryo testing before Christmas. Booster 19 could start testing before year's end. We're watching the first complete Super Heavy booster stacked in 1 month, and Test Tank B 18.3 just survived its 8th torture session. 7 hours of continuous stress testing. This isn't luck. It's a systematic approach to rapid iteration that the aerospace industry claimed was impossible. The Gigabay will double in height. 3 starships per day isn't a fantasy anymore. It's the manufacturing target. And when that production rate hits, everything changes. Orbital data centers, massive satellites, lunar infrastructure, Mars logistics. The bottleneck shifts from launch capability to what we're willing to build. 2026 is shaping up to be the year Super Heavies finally deliver on their promise. New Glenn launching Blue Moon. Starship reaching operational cadence. This is the infrastructure moment we've been waiting for. If this breakdown gave you new insight into SpaceX's V3 breakthrough, hit that like button. Drop a comment on when you think Ship 39 rolls out for testing. Subscribe to Space Update 24 hours so you don't miss what happens next. Because Booster 19's first cryo test is coming fast, and we'll be covering every development. Share this with anyone who thinks aerospace can't move this quickly. They need to see what's actually happening at Starbase.